Welcome to the presentation of the project I have done for the course of Advanced Data Science with IBM in Coursera. So let's go. Okay, for the exercise for Advanced Data Science course, I choose a Kaggle database that is based on volume forecasting. It is because I am interested in exploring it in the supply chain area. So for this reason, I choose this one because it is similar, at least in the database context, um, with the real case scenario that I want to develop in the future. So I choose this one just to start to develop the skills and apply the methodology that I learned during the course. This database course is based for global beer sales. They have a particular case that they want to explore here, so I won't do exactly what they say there. What I want here is to try to select the main SKU of the product that they have and try to predict uh, which are the next volume of the main SKU with uh, the features that we select. So exploring the database, so you can do it here or you can do it in Python right now. So you can see here because they have, for example, for the demography, they have the average of the population, the average of years, of hours, the event calendars are basically the holidays, uh, which is the historical volume, okay, that that they sales, that this particular company sells this based on agencies, products, of course, the volume that they have and the periods. They have which is the whole industry of soda sales in these markets. Also within the industry volume, um, which is the prices and promotion and the weather that they have. So you can see that they have very pretty good features that we can explore to try to make the prediction on on this one. In this example, I also have I choose to use a Jupyter Node with Python and TensorFlow, basically because I start to learn something from TensorFlow before the training. So I am more familiarized and also familiarized with the use of Panda that I use in my daily work. So for this reason, I choose this one. Uh, I am doing the in my computer because there is no a huge manage of data because is is pretty short. So basically, it is the reason why I choose this one. And also because you can work every time that you have a space, you can do in your computer. You don't need to go to the Watson. That is, I guess, more required when you start to develop something harder. Okay, so this is the course. I put initially a text. This is the sorry the program. I select this one first, and then here you can start to see how we will start to running. It's no problem. We start to run one by one just to see the program running. So what I do here is read all the CSV files that they have, um, visualizing again just to see that we are reading the information correctly. Okay, because we saw it in the Kaggle, but now we need to check that we are reading the information. Um, okay, so we are reading each data set and show the first five characters, sorry, the first five rows. So we see here industry volumes. This one I'm running agency, SKU, year, month, price, sales, and promotions. So we visualize this one, so it's just then once we have all of this, one of the constants that they have is when we reach the year month, we don't have in date formats. So what I am doing, so if you see the format that they have, I am changing all the date format to format in terms of dates. So I can make a date operation, date trends, and these kind of things in an easy way. Then what I did is I collect all the CSV and I converge in one single CSV, in one single data frame, in one single panda. So I can get all the information together instead of split information. So here it's already the consultant. So if you can see, so we merge all of these files. Weather is related to agency only, so we merge weather inside the agency and then we merge everything. So now we have a data set that is merging all the information that we have. Okay. Okay. At the end, so we save the file. So starting with the first part, that is the ETL file, we simple save it so we can use it in the next steps. Okay, for the second part, that is the feature engineering file. So we open the Jupyter now using it is again. This is was created our prerequisites of Coursera. Okay, a course for the course Advanced Data Science with IBM. So again, we start to run. So initially, so we just read the library that we need for this file, like NumPy, Pandas, Matplotlib, import. I was making something in the file, so in the second, so all the library that I need, because what I will do here is an interesting part. I will try to go um, um, use um, a different classical machine learning algorithm to try to select the feature of each one, the most important feature, and then so also so we will use the library for the accuracy in the feature selection. So we save a file, we read the file that we save in the previous stage. So then we start to work in the dataset. I am just splitting X and Y. It is a supervised mode. So in the supervised mode, so I am the label, it's volume. So I am separating volume for the rest of the data sets. Okay. So you will see that then I do that. I want to make a correlation. A correlation matrix just to see a heat map with all the correlation. Okay, I will run it. And then you have the correlation with in the whole value. You can see that the FIFA World Cup has no, it's totally blank. So we will remove because they don't have any interaction with other data. So, but for the rest of the data, so we just put a correlation just to see which are the most important feature or which is the relation between one feature and another. Um, then so we drop FIFA Football World Cup because they have no any interaction. Okay. Then in the database, I want to know which are the three top because after we will start to make several ways of feature selection, but I also want to know which are the product with more volume. So XQ1, XQ2, and Q3 are the product that has more volume. So it is practically a good information to take a decision later because many things are part of decisions. So then we make a dummy using um, using Pedego dummy. So this will put um, and important when we try to normalize the data. Uh, just to you to know how this look like. So we can just put to see x. Okay, so if you can see at the right, so we just put the SKU, okay, in the same way that we have already have um, the holidays, okay. So basically, this row represents the SKU 23, and it is the way. So then we normalize the data. It is important part because it's how we select um, how we scale the data to avoid that one feature eat another feature. So trying to put, in this case, I use standard scalar. Was using a standard scalar. Um, we just go. I don't need this one. Split the x and try and test, and then I make a subroutine here that will try to test random forest, linear regression, gradient boost, LGM regression at the same time. So I choose some score. The score that I use, it's a mean square error, absolute error, and root mean square error, and also R2. Why I choose this one? Because it is um, it is what we need when you use data that are not categorical data. So it is continuous data, has continuous data, so it's one the ones, and then I use cross-validate function in order to validate the results using the different methodology. We are using a CAFOL of 5 splits and random state 270. Um, so we just select here, and then so this will take a little bit running because he will go to cross the whole machine learning classical algorithm um, to try to run and provide a result of based on the metric that we choose in order to see what could be the best for our case. So it will take a few minutes. Now the time already already passed, so we have the results here. So in the results, after they run, we have the feed time, the score time. It is the time that they take to run, which is faster than others. It is very important when you have a very huge quantity of data. When you don't have so huge quantity of data, possible the time is not the main concern. But here we can see the accuracy of the data. We can see, for example, that R score is very good in random forest, is the best, and light GBoost it's the second one. Also, XBook is the second one. But when we go to the um, root mean square error, so it seems that Gradient Boost is the best in this case. So it's very short. So we have 2 point of selection. We can use R square or RSMA or the best on that have the both of them. So it's a selection that you need to choose. In my case, I will want to explore the best um, R square and the best root mean square error. So just to see what are the features. So what I did is this one. So I just select to try to see how it's the behavior in the random forest to try to get the feature importance. So I extract this from the web. I didn't put where I get it. I will try to do it for the final um, um, file. So but here it's the random forest. We put model fit. We process the feature importance, and then we print it. So when we print and we see the average of population is the most important feature using random forest, then the average yearly household income, the SQ1, the promotion, SQ3, SQ2. If you remember, SQ1, SQ2, and SQ3 are the products that has more volume, where the promotion is very important. The average max temperature, it's also important. The price. Then we have SQ5, SQ4, industry volume, and then I do the same but using gradient boosting regression because it's what we see that the gradient boosting regression have the it is the shortest value in the RMSA. It is important. The R square, as soon as it's similar to one, it is multiplied by 100. So for this reason, it's 95. But when this is similar to one, is better, and the root mean square, it's the opposite. When it's near to zero, is the best. Is the best. So in this case, so we choose the gradient boost regression because it is the shortest. So now it's the same. So I already put just matter of running just the model, fit the models, um, put the print. I don't need to put this one because I already have in the top, but I was making copy and paste. For this reason, I need to just to clean a little bit the algorithm, the program. But then when we choose this one, pues we go again. So we just run it, run it, and when we run it, so we have again the future importance in the group boosting. It's the average population is 2017. SQ1 now promotion, so it's a little bit different than the previous one. You see, uh, they have some that are the same, but it's a little different. So we decide to explore all the data with the three features we choose SQ, of course, volume, average, and promotion. So for the SQ, we use, of course, the top three SQs that we have, okay, that are SQ1. So we make a graphic just to see the volume, average temperature, and the promotion. That are the three features that we select to go to the deep learning part. Also for the SQ2, we have this one, and this one. And for SQ3, so these are the graph. Okay. So with this part, we just complete, I guess, the part of feature selection is not totally complete because I did in this way because I can save the data for the next step. But in the next step, I possibly would do some part of feature engineering. Okay, now we will run the definition model. In the definition model, how it's a little bit complex to try to create a model that fit your case. I guess is the one of the challenge that the people could face. It was my case at least. I am doing like a special of brute force like I did in the previous stage where I take all the machine learning algorithm, classical algorithm and try to run out of them to check which is the feature selection. I will do the same. But here in two cases, I will choose all way to scalar the database, and I will also try to run a bunch of model. It will take so many time, so I will just put one case here of Scora. I already did this several times just to select which is what I need in the first stage right now for the model. So for the presentation case, so I just start to run this one to choose you one case and then the results of all of them. So we read the previous data set that we have. We just choose the XQ01. We have these two functions. That is a univariate data function. If you want to learn about how to structure the time series, I recommend you to go to this TensorFlow tutorial. This pretty well. So in this univariate data, what we are doing is try to choose um, in a supervised model, which is the target, which is the label that we are choosing. So what we are doing is we are split each series in 3 steps. In my case, I am using 3 steps. You can use wherever you need for your case. So I select 3 cases, and the 4 cases, that is the fourth point of the data set, it's the label. So then I choose the following, starting in the second point, third point, and fourth point, and the fifth point is the label, and you're going this way. How I have 60 data point, when you choose this, when you lose one, you lose the last one, because the last one will be an X and won't be in the Y part, in the X part. Will be a Y, sorry, and not in the X part. So I also take for this tutorial the 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 plot of the training and loss, validation loss error. It's pretty good, interesting, because I will use it to design which model I want to use. So let me run this one. Uh, and in my case, I have 60 data points. So we're split it in 50 months for the training set, 3 for validation. And you see, you lose one. That is the last one when you convert. So you have 50 and 53. So this means one is 54. So you have 6 for the the for the test set. Okay. So in this case, it is what I showed you, that I already test all of this. It was the best that fits my case. So, but this is the case. So I take first one, this one, for all my database with all different models, just to figure out which is the model that best fits my case. So it's like a brute force analysis of technology here, just to see which is the best one. This is to use the univariate uh, function that we have in the previous part. Um, it's what I told you. I select 3 only, and the target site 0. It means they will only have one input, one output. Sorry. So you have this case where I select. I manage my data, so just to get at the end of the day a matrix where 3 dimensions, okay, x1 and x2, where x is the volume, x2 is the temperature, and x2 is the promotions. So in this case, so we have the test sets, the training set, and the test sets, and the validation tests. So if you see, I choose training set. That is the variable that I defined previously. Then from training to train value are the 3 points that I defined from the value, and the rest is test set. So when we run this one, and then we have the model. Okay, I didn't run. I forgot to run this one. I forgot to run this one and forgot what's up in here. Ah, and now to run here. So now we are okay. In the in the in the model sequences, so I will show you this one. That is one of the first that I define. If you will see the program, I define many models. Here we're using MSE. Here we're using mean absolute error, mean square error. In this case, here we're using mean square error. Then I have LSTM 300, 200, 150 using ReLO, return sequences, and with my and Adam. And I have another one with 300, 200, 150, but now using MSE, mean square error, optimizer Adam also. Then I have another one with 300, 200, 150 with a dropout of 0.2 in the second layer. So I start to create a bunch of models that could fit in my cases. Of course, I start with ones, and then depending of the result, I start to create another. This is how I start to build many models just to figure out what's going on. So I create many of them. It's not the best efficient way, especially when you have in a deep learning bunch of data data, but in my case, it's pretty good. So I guess in 30, 40 minutes, this could run without problem. So let's just to try to run the next one. It will take some minutes, so I will come back in a little bit when it is done because it will take some time. So now they are ready to run. It takes like a 3 minutes to do it, 2 to 3 minutes. So he makes the first model in the validation test. We have an R2 of 0.66, an MSE of 0.00, and RMSE of 0.05. The triangle validation looks pretty good, but if you can see that is below the training loss set, that is good. So we will run the comparison with the test sets. So now that we have the test set, so the test set have a pretty good numbers, you see. It didn't happen with other scalar methods to get this one, but it's pretty good. So it was the best that I found. So let me run the rest of model and return back with you so you can see all the graphics and the results of the other ones. Now we are done with the rest of the models. They are already run. So when we see, so I want just to explore each of them because I put to run everything okay again. So I start to see which are the number for the GRU and GRU using mean square error. So pretty good graphic with good number in the validation. With the validation data, which with the prediction, they're not pretty good in this case. Using LSTM, we have a very good scenarios in the validation test. This is pretty good in the number. If you see the RMSE, it's 0.0085. So we start to see each of them just to see, well, Josu, this is look pretty good. So which is this one? It is using MSE with LSTM 300, 200, 150. So we have pretty good number here. We have an RSME that is very low. There are still, it's not good, but the RSME is good. The graphic look with the trend, that's the pattern. This is, this is the real movement. It is, how the algorithm is trying to follow the, the real movement. So I make this one with a dropout of 0.2. This also look pretty well. The numbers are pretty well in the validation sets, in the test sets. They are also pretty good. And if you see the trend try to follow a little bit quicker the test, we'll go with the next one doing the same scenario. So this is also pretty good. They have a very good number, 0.14. The R score is 1, minus 1.2. It's greater than 2, than 1. That is means something where. This look also pretty good. You see this RSMS in the validation text is very slow. So this look pretty good also. So we have a bunch of model where we can evaluate just to see how is the behavior and the RMSE of each one. So this is look pretty well. The room, oh, this root mean square is pretty low. Okay, which model it is? It is with a dropout of 0.4. So we have all of these cases. They follow the trend. That is pretty good. Very good root mean square error. This also have our, but this is the other one. Okay, other models that we have, how it's the behavior at the final test. Okay, this one, another one. So you see, a bunch of models just to see what is the best for me. What I understand, the one of the goods, it's this one, I guess. No, this one, no. This one is one of the best if I will take the RMSE model. And they have a very pretty good in the validation test, so it's a model that we can fit. I will try to use this in the next step just to evaluate if the three of them are pretty good. So we will see it. Let's go to the next part. Now for the last one, for the last part, I make just one Jupyter notes that take the training and evaluation and everything. So this is the last part, just to see how our model behave with the three SKU that I want to see. So I already run the program, so you already saw in the last part how they run. So what I did here is practically the same thing. Just copy the library, read the dataset, select the XU1, the two library that I need, that is the univariate data, the plot. That I select the data. I am just plating here the max scalar. I am not putting all the rest even in common because the other way used for the modeling, but for here I already understand that this is the best for me, that best fit my case. So I select prepare my data. I choose the model that we chose in the previous one, that is using the dropout 0.4. So here I run the epoch. I again have a pretty good shape in this one, and also have a pretty good shape in this one. I have a very good RSMA. With the SQO2, we have the same thing. We run the model. We create the test validation. Looks pretty well for the SQ2, and for the test sets, uh, they look also pretty good. The RSMA is pretty low in this case. It's look like a, they follow the trends. I go with the SQO3, do the same thing, same result in the modeling, pretty good results also in the test part. So, it is done. I hope you have enjoyed the project, and thank you for taking the time to watch the video. Bye.